Okay, let's look at systems of inequalities. So first of all, a system of equations that is a, a set of two or more, so two plus, the two or more equations. And our inequality signs, we've got, of course, greater or less than, or greater than, or equal to, or less than or equal to. So the boundary lines for it, which would be the lines that we're really graphing, if it's less than or greater than, then that's going to be a dotted line. So we'll have dotted lines just like we had the open circles. So you can think of open circle, dotted line, all go for less than or greater than. Then the less than or equal to, greater than or equal to, that's going to be my solid line. So that solid line just means that could be included in it. And so that's going to be like our filled in dot. So we want to know which one of these points would be a solution to the system of equations. And so when we're looking, when it shows it to you like this, the part that's true for both would be where it's shaded. So this one's shaded down, this one's shaded to the right. So we're looking, anything in this area here is going to be something that works for it. So if it ends up on the dotted line, then it's not going to count. If it ends up on the solid line, it will count. So let's see. Let's put the points. Negative 2, 4. So negative 2, 1, 2, 3, 4. Doesn't work. 1, 3 is right there. Also does not work. For 6, 1, 2, 3, 4, 5, 6. Up 2. Looks like that does work. It's on the line, but on the line is okay with us as long as it's solid. And over 4, so 4, 0 would work. And then negative 2, up 6 would be up here, and that doesn't work. That is out of the way for all of them. So looking for a solution to it is just finding anything that's a dot that is on the solid line or inside the shaded area. So on solid or in shaded. And we say in shaded, just make sure it's in the area that's shaded for both. So let's solve it and find the solution to the system of inequalities here. First one, x is greater than or equal to 2. So I'll put a line on x equals 2. I'm making that a solid line because that's greater than or equal to. And then it's greater than. So greater than is going to be going up this way. So easy enough to figure out for my just x equals that it's going up that way. Then I have x minus y equals 3. So let's change that to slope-intercept real quick. Subtract x from both sides. Then I have negative y greater than 3 minus x. Now I've got to be careful about when I'm dividing by a negative 1 here, that's going to change my sign around. So I'd have y is less than x minus 3. Okay, because I divided by negative 1, that would flip it around. We could also plug in a couple numbers for x and y. I normally use 0 for each, and find our x and y intercept. It's another way to graph the line without having to worry about flipping that around. Once we do this though, I get a -3, and then a slope of 1. So doing my dots, that this will be a just less than. So what I do is I kind of connect every other dot, and it gets me a dotted line. So if we labeled those A and B, it would be line A, this would be line B. Now deciding which way this goes, what I do is I do a quick test. So I'm going to test 0, 0. So if I put in 0 for both of these, does it make it a true statement? 0 minus 0 is greater than 3. So 0 greater than 3, that is false. So that means the origin will not be shaded. So in other words, it's shaded down this way like this. So the part I'm looking for is right here where both are shaded. And I'll start testing points. So going from 1 down to -3. Right there, it's outside of it, so that does not work. Going over 1, 2, 3, and up 0. That's right on the dotted line. Because it's on a dotted line, we can't use that one. So over 2, down to -3. That is on a solid line. So on solid means it's good to go. And then -1, -2 doesn't work for us. And over 1, 2, 3, 4, down to -2 is in shaded, so it works for us. As we're graphing these, pay close attention to your signs that tell you your boundary lines and to your tests to decide which way you're going to shade it, down or up or to the left or right.